This example is about homogeneous linear differential equation. The question asks you to solve following differential equation, which is y double prime minus 10y prime plus 25y equal to 0. Based on this equation, we can form it into auxiliary equation, which is m squared minus 10m plus 25 equal to 0. So here we need to solve for auxiliary equation. So based on this equation, we can factorize it. Then we have m minus 5, the whole thing to the power of 2 equal to 0. So based on this, we identified that we have a repeated root, which is m1 equal to m2, which is equal to 5. Therefore, our general solution here is y of x equal to c1 exponent of 5x plus c2 x exponent of 5x. This solution is based on y of x, c1 exponent of mx plus c2 x exponent of mx. In this example, we need to solve following differential equation, which is 2y double prime minus 5y prime minus 3y equal to 0. It is still homogeneous linear differential equation because our g of x equal to 0. Based on this equation, we can form it into auxiliary equation, which is 2m squared minus 5m minus 3 equal to 0. This equation can be factorized, and we have 2m plus 1 times m minus 3 equal to 0. So based on this equation, we identified that our m1 here is a negative 1 over 2 and m2 here is 3. So here we can say that this root is about two distinct real roots. Based on this root, our general solution is y of x, it is equal c1 exponent of m1x plus c2 exponent of m2x. Therefore, our general solution here is y of x, it is equivalent with c1 exponent of negative 1 over 2x plus c2 exponent of 3x. In this example, we want to discuss how to solve the different equation for y double prime plus y prime plus y equal to 0. Based on this equation, we can form it into auxiliary equation, which is m squared plus m plus 1 equal to 0. Based on this equation, we can solve it by factorize, but we need to use quadratic equation formula, which is m equal to negative b plus minus square root of b squared minus 4ac over 2a. Based on this equation, our a here is 1, our b here is 1, and our c is also 1. Right, so therefore, our root or our m here is negative 1 plus minus square root 1 minus 4 times 1 over 2 times 1, and it is also equivalent with negative 1 plus minus square root negative 3 over 2. So our problem here is we have this term, which is the square root negative 3. This square root negative 3, we can factorize it. Then we have a square root of negative 1 times, square root negative 1 times 3. And it is also equivalent with square root negative 1 times square root of 3. In mathematics, if you have square root negative 1, it is related with complex number. We identified it as a I. Okay, so therefore square root negative 3, it is also equivalent with square root of 3i. Therefore, our root here is negative 1 over 2 plus minus square root of 3 over 2i. So this root is about complex root. Based on second order homogeneous second order linear differential equation if you have complex root. So our general solution will be y of x equivalent with exponent of ax times c1 cosine of bx plus c2 cosine of bx. Therefore, our general solution here is exponent of negative 1 over 2x times c1 cosine square root of 3 over 2x plus c2 sine square root of 3 over 2x.